So today, for this section, we are discussing the basic probability rules. All right. So at the end of this discussion, what you should be able to do is I can find probability percentages and determine both conditional and regular, it's supposed to be an and regular probability. So this is the formal mathematical definition of probability. So a value that represents the likelihood of an event. So fraction, decimal, or percentage. If you have 0, that means never. That event will never happen, okay? If I have a probability of 1 or 100%, that means that will always happen. All right. So, and then formally, your probability is defined as a fraction, the total number of favorable outcomes divided by the total number of possible outcomes. So it's essentially a chance process. What is your chance of something happening? So, and informally, okay, it's the number of what you want over the number possible. All right. So let's look at a sample space of rolling a 6-sided dice. So if I have a dice, so 1, 2, there's 3 sides of my dice, okay? If I roll a dice, obviously there is one side is going to show up, and that's the dice roll, all right? So the sample space is our values that are going to be, if I roll all possible choices, if I roll over and over and I get all possible choices, my choices are 1, 2, 3, 4, 5, and 6, okay? So the total possible, and when it's asking for the number. So what's our sample space number? Well, it's 6 because there's 6 choices. Okay? So all of these probabilities down below in this table, all of these probabilities are out of the number possible. So what is our number possible? So it's out of 6. So our chance is always going to be out of 6 choices. Okay? So what is our probability of an even number? Well, what numbers are even out of our sample space set? I could roll a 2, a 4, or a 6. How many choices is that? That's 3. So that is 1/2 as a reduced fraction, 0.5 as a decimal, 50% as a probability, okay? So let's look at the next probability, which is prime numbers. So out of our sample space, what numbers are prime? 1 is prime, 2 is prime, 3 is prime, and 5 is prime. Okay, how many numbers are prime out of that set that we're looking at? Is 4. So my reduced fraction is 2/3. That's 0.666 repeating. That equals 66.7%. Please note that we are essentially rounding off to 1 decimal place, okay, for your percent values. All right, the next two can be a little bit tricky, but what I'm looking at, all right, is what numbers are less than 7. So if I look at my sample space up here, right, what numbers are actually less than 7 in this sample space? Well, 1 is less than 7, 2 is less than 7, 3, 4, 5, 6. All of those numbers are less than 7. So how many of them are less than 7? Well, 6. Okay, so every single value is less than 7. That's a value of 1, 100%. In other words, no matter what you roll on the dice, you will roll a number less than 7. There's no other options available to you. Okay? Same idea for numbers greater than 7. Well, if I look at these numbers, just to be clear, if I look at these numbers, 1, 2, 3, 4, 5, 6, which are the numbers I'm choosing from, well, guess what? That one, all of them are smaller than 7. So none of these are actually possible. So my actual chance here is 0. I will never be able to roll a number less than 7, greater than 7. If I want to win my game and rolling a number greater than 7, that is never going to happen. So that probability is 0, never, and that's a 0% set. Okay, so that's your basic idea with a sample space. Right. If you're taking notes on this, I would suggest you now turn to the back page of your notes packet, which has a blank sheet, and we're going to look at a couple other ideas, okay? So one of the probabilities that you'll see a lot, like on tests, standardized tests, and so on in general, is like card decks, okay? So this is a standard deck of cards. It's showing every card. And you'll note that essentially if I'm looking at this, I've got 4 suits. I've got clubs, spades, hearts, diamonds. Okay? It should, if we look at a suit, there are 13 cards in every suit. So my full deck is, this full deck altogether is 52 cards. So if I'm looking at my space as a card deck, then the number of cards is 52 cards. Okay? Let's look at a couple of probabilities. So what is the probability that I'm going to choose a red card out of this deck? So if I look at this card deck and I look at black cards versus red cards, you should be able to see that if I circle the red cards, that is essentially half of the cards available to me. So by looking at the actual deck, I should be able to see that is 1/2. If I count the cards, well, I've got 13 red cards here and 13 red cards here. So 13 hearts, 13 diamonds. So if I'm looking at it that way, I have 26 cards out of 52 cards, okay, which is also 1/2, all right? So essentially, whether I count the cards or whether I'm looking at the set, the probability is the same, and that is a 50% probability, okay? What is then the probability of pulling a heart out of this deck? Well, let's look at that. Here are the heart cards. These are all the hearts in the deck. Well, I have 4 suits. This is 1 suit. So what is my actual probability of a random choice? 1 out of 4 choices. Okay? If I count the cards, there are 13 hearts out of 52 total cards. Again, 1/4. What is that? 25% probability. All right? So this is standard probability, okay? Standard probability basically says you're using the entire sample space as your set, and then you're just figuring out how many of what you want over the total cards, okay? Let's do a couple. Let's do at least one more. So let's say the probability of pulling a face card. So I know my total set is 52 because there's 52 cards in the deck. If I look at my cards, these are the face cards. So how many cards do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So in this deck, in a standard deck, there are 12 face cards. So what is my probability? 12 out of 52, or that reduces to 3 out of 13. That is equal to 0.2308. Okay, so I would say that basically my actual probability percentage, 23%, or 23.1%, I would consider those both correct. Actually, this is probably a little bit more accurate because I said to round off to 1 decimal place. So 23.1% is the probability of pulling a face card out of the deck randomly. Okay. One more thing. This is chance of something happening. So nothing's happened yet. Okay. So my chance of a face card is 23%. If I then shuffle my deck and I pull out this card here, let's say I just randomly pull 5 of hearts, well then my actual event was I pulled the 5 of hearts, and now that's actual what happened, okay? So be clear that probability is nothing's happened yet, okay? Once something happens, then that's an actual event that occurred, and that's no longer a chance, all right? So this is regular probability where you're pulling out of the entire set. So the next kind of thing we want to talk about, the next major concept here, is what's called conditional probability. And conditional probability means use a subset as the sample space. All right. The word, the math word, is given. So probability, let's look at a probability set this way. So a probability of a face card given face cards. All right. So when we're doing probability statements, this little vertical line means the word given. All right. And this here is the new subset sample space. All right. So what I'm doing is figuring out my probability And on the bottom is the number of face cards, because that is my new sample space. All right? So if I look at my card deck and I say, okay, you know what? All of these cards, everything that's not a face card, all right, which is all of everything else, basically is not part of your choices anymore, all right? So we are changing the sample space. We're not using the entire deck anymore. Now we're only using face cards. So we look at the face cards and I say, okay, I'm only choosing out of that. So I've handed you a smaller stack of cards, and these are the only cards you have in your hands, all right? So how many cards are in the new space? Well, that's 12. So if I go over here, then I'm choosing out of 12 cards. All right, so that's the sample space set. Okay, probability of face given face. So what is the probability of now pulling a face card, right? So this is the number that goes on the top. So I look and see out of this set I've chosen, so the highlighted yellow cards are the ones that I'm pulling from, and I want to look and see out of this set how many are face cards. So I'm highlighting all the face cards, and what I see is there's actually 12 face cards in that set that I'm choosing from, okay? So here I go. What do I say? 12, 12. And this actually makes sense. So the probability of face cards given a face card is 1 or 100%. Okay? One more example. What is the probability of a jack in the entire deck? Okay. Probability of a jack out of the entire deck. Okay? So I'm looking at jack cards. Here's the cards that are jacks. How many cards in the deck are jacks? Well, I should be able to see that there is 4 jacks. So the probability of a jack is 4. And since I'm not doing a conditional set, basically, what am I pulling from? The entire deck. So my space is the deck, and that's 52. So that equals 1 out of 13. Which is 0.0769 or 7.7%. All right, last probability on this set. Probability of a jack given a face. Okay, so now what? Now we're saying that I'm telling you, given a face card, so I'm saying only the face cards. I've now subsetted my set, so you only have face cards. So my sample space is now 12. The jacks that are in that sample space is 4. All right. So what is my probability of that? It's essentially 4 out of 12, 1 out of 3, 33.3%. So the main idea here about main probability versus conditional is conditional probability changes your sample space. And this is a pretty good example of how it works. Okay. All right, so we're going to head back over to the notes.